Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at 3D figures and their parts. We're going to start with some vocabulary here. A plane is a two-dimensional flat surface that extends in all directions. There are different ways that planes can be related in space, and I apologize for the typo here. That word should be planes with an E. My apologies. They can intersect in a line, as you can see here from this diagram. They can intersect in a point, and they could also have no intersection at all, where they are called parallel planes. So that's something that you're going to want to pay attention to. That's going to pop up later today again in these guided notes. The word solid refers to a three-dimensional figure formed by intersecting planes. Polyhedron is a solid with flat surfaces that are polygons. Polyhedrons can be made up of edges, faces, and vertices. And in case you do not remember what the word polygons mean, they are things such as rectangles, squares, triangles, parallelograms, trapezoids, hexagons, pentagons, and so on. So that's what polygons are referring to. And as you can see from this diagram of the cube that I have drawn for you, we have some more vocabulary here. An edge is where two planes intersect in a line. A face is a flat surface, and a vertex is where three or more planes intersect in a point. At the bottom of the page, we have diagrams trying to show you the difference here between prisms versus pyramids, both of which are polyhedrons. Starting off with three-dimensional shapes that are based on a two-dimensional base being a rectangle, we have the rectangular prism. You can see it has two bases here. And we have the rectangular pyramid that has one base. And then we have three-dimensional figures based on the idea of having a base of a triangle. Triangular prism has two triangular bases, and a triangular pyramid would have just one triangular base. At the top of the next page, let's fill in some blanks here. And this relates to the chart that we were just looking at. Prisms have how many bases? Well, if you were following along, they have two bases. And those two bases will always be parallel and congruent to each other. You can fill in those blanks. Let me show you what I mean. With the rectangular prism, those two rectangles will always be parallel to each other and congruent to each other. The word congruent means the exact same size. With the triangular prism, same thing. They have two triangles that are parallel and congruent to each other. This will always be the case with any type of prism. Now, what about the other faces, the ones that aren't bases? What is always true about them? Well, they're always going to be rectangles. Fill in that blank. If you look back at the diagram, you'll see what I mean. Between the two rectangles that were parallel and congruent to each other, we had four rectangles that were in between for the other faces. For the triangular prism, in between the two triangular bases, we have three rectangles in between. The third one you can't really see, would be in the back, but that would be in between the two triangular bases. So this is always going to be true about prisms. The other faces that are not bases will always be rectangles, and those rectangular faces will always go in between the two bases. Now, what's true about pyramids? They will always only have one base. And the other faces that will come off of the base will always be triangles. So fill in that blank. And you'll see what I mean here if you look at the diagrams we had for the rectangular pyramid and the triangular pyramid. Coming off the one rectangular base, we had four triangles meeting at a point. Coming off of the one triangular base, we had three other triangles, again, coming up at a point. So that's what I'm talking about, that pyramids will only have one base, and the other faces that will come off of that base will always be triangles. So use this top part of the guided notes to help you to distinguish between prisms and pyramids. Now, I should note that despite what the chart on the first page was showing you, sometimes prisms and pyramids will be facing in a direction where its base or bases might actually be in the front and in the back instead of being at the bottom. So here's two examples. Here's one of a triangular prism where the bases are in the front and the back. Again, the two triangles that are parallel and congruent to each other, they would be the bases here, not the rectangle at the bottom. but it's the two triangles that are parallel and congruent to each other that determine the bases of a prism. You can see over here we have a hexagonal prism where there's a hexagon in the front and a hexagon in the back that are parallel and congruent to each other. We've always said above that there's going to be rectangles in between the two bases of any kind of prism. You'll see there's 6 different rectangles here wrapping around at the top, going around to the bottom and on the sides. So once again, the hexagons were not on the top and the bottom. They happen to be in the front and the back. So please realize this definitely could happen not just with prisms, but also possibly with pyramids. All right, so with that in mind, I would like for you to hit pause and do these next 2 problems on your own. Hit pause, try these 2 on your own, and then hit play when you're ready to see how you did. Okay, I hope you already did number 1 and number 2 on your own. Number 1, which of the following is not a prism? Well, it is choice D, because choice D is actually a pyramid. We have the rectangular base at the bottom, and coming off of that rectangular base, we have 4 different triangles. So that's definitely a pyramid. It is not a prism, because a prism would have to have 2 parallel shapes that are congruent to each other, and that's not the case here on choice D. You'll see on choice A, we had 2 trapezoids that were parallel and congruent to each other, the one in the front and the one in the back. Sorry that I'm not outlining these very well, but you can see what I mean. Those 2 trapezoids are parallel to each other, and in between we have rectangles. That's the qualities of a prism, just like we talked about at the top of this page. Choice B was a triangular prism. We had a triangle in the front and a triangle just like it in the back. Again, I apologize, I'm not outlining them very well. But those 2 parallel congruent triangles make this a triangular prism. And you'll see there's 3 rectangles in between connecting those 2 triangles. Choice C was a pentagonal prism. There's a pentagon at the top, and there's one you can't really see that would be at the bottom. In between, we have the rectangle. So again, these are qualities of a prism. That's why the one that was not a prism was choice D. All right, what about problem number 2? Which of the following is a triangular pyramid? Well, it was choice C. Choice C had a triangular base. You can see I made it a little dark here for you. And coming off of that triangular base, we had 3 triangles. That's the qualities of a triangular pyramid. Choice A was a rectangular pyramid. Choice B was not a pyramid at all. We had a triangle in the front and a triangle that was exactly like it, parallel to it in the back, and rectangles are in between. So choice B was actually a triangular prism. Choice D was a pyramid, but it was a trapezoidal pyramid. The base is actually at the top here, so this is kind of upside down, and there were triangles coming off of that trapezoidal base, so that is why choice D was a trapezoidal prism. All right, the next section of the guided notes shows you the difference between cylinders, cones, and spheres. All of these are shapes that are 3-dimensional that come off of a 2-dimensional base, being a circle. Cylinders, you will see, have 2 circular bases. Again, they're parallel, congruent to each other, just like a prism. A cone has 1 base, and then you have this part kind of like a pyramid coming to a point at the top, except it's rounded in nature going around. So that makes it a cone, not a pyramid. And then a sphere is basically what you would call in real life a ball. In geometry, we call it a sphere. It does not have a base at all, but is like a 3-dimensional circle. So let's compare cylinders to prisms. I actually kind of already did this if you were listening earlier. Cylinders have something very much in common with prisms. They both have 2 bases, to fill in those blanks, that happen to be parallel and congruent to each other. However, the bases of a cylinder will always be circles, whereas the bases of prisms will always be polygons. If you have to pause the video to fill in those blanks, feel free to do so. Now, some tips on naming a 3D shape and its bases. Prisms and pyramids are named using 2 words. The first word is always going to refer to the base, okay, or bases. So that first word could be things like rectangular if the bases are rectangles, or square if the bases are squares, or trapezoidal if the bases are trapezoids, or triangular if the bases are triangles. The second word is always going to be the word prism or pyramid. Again, if we're talking about a prism or a pyramid. If we're talking about a cylinder or a cone, then that's a different story. But if we're talking about prisms and pyramids, then the first word will always refer to the bases, and the second word will always refer to the word prism or pyramid, depending on which one it is. When you name the bases of a prism or pyramid, use the letters that come from each vertex of the base. You'll see what I mean when we do some examples here together. You may go in clockwise or counterclockwise order when you write the letters of the base. When you name the bases of a cylinder or the base of a cone, you will write the word circle, followed by the one and only letter that is labeled to the point of the center of that circle. All right, so let's do some examples together. The directions say identify each solid, which means state its name. And then part two of the directions, name the base, or it could be bases. It could be plural. Remember, prisms and cylinders have more than one base that happen to be parallel and congruent to each other. All right, so problem number one. Can you figure out why this is a triangular prism and not some kind of pyramid? Hit pause in the video and think about that, and then hit play when you're ready to hear me explain it. All right, hopefully you have already hit pause in the video and thought for yourself why problem number one is a triangular prism instead of some type of pyramid. It's because there's a triangle at the top and a triangle at the bottom that are the exact same triangle, so they are congruent, and they are parallel to each other. They go in the exact same direction. That's what parallel means. So that can only be true with a prism, not a pyramid, having two bases that are parallel and congruent to each other. And since those two bases are both triangles, that is why this is a triangular prism. The other reason why we know number one is a prism is because between these two triangles, we have three rectangles, the big one in the front and the two that are in the back, and that can only exist with prisms. A pyramid could never have more than one rectangle, and that's only if the base would be a rectangle. With a pyramid, the other faces are always triangles. So there you go. Those are the reasons why number one is a triangular prism. And you will see I named those bases with the three vertices that were on each of the triangles. So the triangle at the bottom had vertices J, K, and L going in counterclockwise order. And the triangle on the top had the vertices of F, G, and H, again going in counterclockwise order. If you want, you could go in clockwise order instead. All right, let's do number two together. First of all, is this a prism or is this a pyramid? Well, this was probably pretty obvious to you. There's one rectangle here on the bottom, and then there's four different triangles coming from that rectangle, all meeting at a point at the top. So this is definitely a pyramid, and since the base is a rectangle, it is a rectangular pyramid. So go ahead and write that down. Now, we have to name the base of the rectangle. You can go in any order you want. I chose to go once again in counterclockwise order. So I went R, S, and then T and U. I did not write down the V because the V is not on the rectangle. We are only using the vertices that are on the base. All right. I would like for you to try numbers 3 and 4 on your own. So hit pause on the video, do 3 and 4 on your own, then hit play when you're ready to see how you did. All right, I hope you already did 3 and 4 on your own. Problem number 3 was a triangular pyramid. How do we know? Because there's a triangle at the bottom, and coming off of that triangle are more triangles. So that is a triangular pyramid, definitely not a prism. A prism would have to have two triangles parallel and congruent to each other with rectangles in between, kind of like we saw in number 1. So number 3 is definitely not that. It is a triangular pyramid. And you can name that triangle at the bottom with the letters C, D, and E in any order you want. Hopefully you did not choose the letter F, since that was not on the base for this triangular pyramid. All right, problem number 4 is a rectangular prism. We know this because there's actually more than two rectangles that are parallel and congruent to each other. Probably most of you named the rectangle that was at the bottom and the rectangle that is parallel and congruent to it on the top as the two bases. So that would be like KLMN and PQRS. But you could actually have named the big rectangle in the front and the one that's like it in the back as the bases. You could have even named the rectangle on the left side and right side. They are also parallel and congruent to each other. So bottom line, you could have named any pair of parallel congruent rectangles as the names of the bases for problem number 4. All right, I would like for you to try number 5, number 6, number 7, number 8, and 9 on your own. If you don't remember how to name cones and cylinders, remember the tips that I gave at the top of the page to assist you with those problems. So hit pause on the video, complete the rest of the problems on this page, and then hit play when you're ready to see how you did. All right, I hope you already did numbers 5, 6, 7, 8, and 9. If you did not, you really need to hit pause on the video and do those problems right now on your own. Problem number 5 is definitely a cone. And when you name a cone, it just has one name. It's just cone. The only ones that have 2 words to them are the prisms and the pyramids, where the first word refers to the type of base that you're dealing with. But with the cone, it's just called a cone. The base is circle C. So that's how you name the base of a cone or a cylinder, is you just call it a circle and then you name it with the point that was labeled in the center of that circle. Problem number 6 was a pentagonal prism. Now, how did I know? Because there's a pentagon in the front and there's a pentagon that's exactly like it in the back, and they are parallel and congruent to each other. So that's why it's a pentagonal prism and not some other type of prism. Now, I hope that you did not accidentally name the rectangle that's at the bottom as the base, because it's not parallel and congruent to anything. And so therefore, it's not the base of this prism. The bases of this prism are the 2 pentagons. Remember, I told you earlier in this packet of guided notes that bases are not always at the bottom. Sometimes they're in the front and in the back. And that's the case that we have here on number 6. So if you accidentally named the base as the rectangle at the bottom, hit pause on the video, erase what you had, and fix it, naming it with the 2 pentagons. And you can go in any order you want. Here I named the bases as F, G, H, I, and J. I went in counterclockwise order, and then for the one in the back I named it again in counterclockwise order, A, B, C, D, E, but you can go in clockwise order if you want, no big deal. All right, problem number 7. This was a pyramid for sure. It's kind of on its side. This is a rectangular pyramid. If you named it a square pyramid, I kind of don't blame you, because the rectangle here does almost look like a square. It's a little unclear if the left and right side are the same measures as the top and bottom. So that's why I kind of played it safe and called it a rectangular pyramid instead of a square pyramid. Hopefully you named the rectangle as the base. You can go in any order you want. I started with the letter A to kind of go alphabetical here, and then I went in counterclockwise order, A, B, C, D. Problem number 8 is a triangular prism. How do I know? Because there's a triangle in the front and one very much like it in the back that are parallel and congruent to each other. That's why it's a triangular prism instead of a rectangular prism, and it's definitely not a pyramid, because there's 3 rectangles, the one here on the top, the one here on the right side, and the one at the bottom, that are in between those 2 triangles. So that's why it's a triangular prism. Hopefully you named the 2 triangles either in clockwise or counterclockwise order, using only the letters on each of those 3 triangles. All right, problem number 9 is a cylinder. Now, it's a cylinder on its side. Normally we see cylinders with the circles on the top and bottom, but here it's on the sides. Hopefully you named the 2 circles, circles M and circle N, as your 2 bases. All right, and that concludes the guided notes for Math Grade 7. Pre-algebra, you have 1 final page, which I'll do in a separate video. So thank you for watching. We'll see you next time.